I showed you the playground last time for a simple example, but this time I want to use it to demonstrate the most important elements of the Marlowe language. And as I mentioned last time, there are different ways to actually write Marlowe contracts, and we'll look at those two, JavaScript or Haskell, in more detail in the next lecture. But in this lecture, I want to concentrate on these two, typing Marlowe directly or using Blockly. And arguably the nicest way, especially for beginners, to get started with Marlowe is using Blockly, where you can assemble your contracts by mostly using the mouse. So you don't have to type any code with the keyboard. So the arguably most simple Marlowe contract is the one that just closes. So if we send that to the simulator and start the simulation, it immediately ends and nothing has happened. So that's quite boring. So let's go back to Blockly. And the concept of Blockly is that you have this contract. At the moment, it's just closed, but let's remove that now. And you can fill in building blocks into these holes here. And there are various types of blocks, and the holes are shaped accordingly. So basically, visually, you can see what you can enter in various holes. So let's start very simple by writing a contract where there are two participants, a giver and a receiver, and the giver sends 100 ADA to the receiver. Now, of course, in order to do that, you wouldn't need Marlowe. You can just use your wallet. But nevertheless, let's try to do that in Marlowe. And maybe it's a bad example because in Marlowe, it's actually more complicated, much more complicated than it would be to simply use your wallet. But of course, Marlowe offers many features that then make things very easy in Marlowe that are impossible or at least very difficult to achieve with other means. So if we click here on contract, this pops up and that tells us what we need to fill this hole. So if we click on base contract type, then we will actually get the contents of this menu item here, but let's click on it. So we see we have 1, 2, 3, 4, 5, 6 options to fill this hole. Close we already saw, so that's boring. So let's look at the other 4. Actually, assert we will also ignore. That will probably be deprecated soon. So the interesting ones for us are those 4. Now pay looks promising because we want to do a payment from the giver participant to the receiver participant. However, we can't use that directly because payment in Marlowe always goes from an internal account to either another internal account or to a wallet. I mentioned internal accounts before. So the concept is that in Marlowe, each participant also has a so-called internal account. So I briefly explained last time that the state of a Marlowe contract is represented by a UTXO on the blockchain, an unspent transaction output, and that UTXO contains some data, but also value. Can be ADA, can be other tokens. So internally, there's some bookkeeping that says how much of that value contained in the contract belongs to what internal account, and each participant has one. I mean, the value is all lumped up in this UTXO, but the data associated with the UTXO keeps track of to which internal account how much of the value belongs. And payments, so this here, this pay, can only originate from internal accounts. So if we want to make a payment in Marlowe, we first must get some funds into an internal account. Now, that means we need the giver to make a deposit into the account. And that is something the contract can't enforce. I mentioned that last time. There are actions that the participants of the contract must perform, and you can't force them to do that. And for situations like that, when you expect one of the participants of the contract to do something, we need this when construct. So let's use that. and let's see whether it fits into this hole. It doesn't look as if it will, but actually it does. So this hole just gets bigger. And now we see that we have more holes. And we have to set a timeout. I also mentioned that last time. That is a very important concept in Marlowe, that everything has a finite time. So no money can be locked in a Marlowe contract forever. And this is enforced by insisting on timeouts for when clauses. So we see there is constant timeouts and also parameterized timeouts. When we give a constant timeout, we, as the name suggests, must give a constant time. So let's try a constant first, and let me just pick something far in the future so that I don't have the issue that when I actually try the contract, the timeout lies already in the past. So let's just pick something in 2023. Let's say 1st of January 2023. The time doesn't matter. Okay, so that's the first thing. Now we have these two more holes, and if I click here on the when, I actually see the types of those holes. So I need case and I need a contract. So what does that mean? Case is what actions from participants I'm waiting for. So in our case, that will be a deposit because I'm waiting for the giver to make a deposit into the contract. And then this continue as, the contract is what is supposed to happen when the timeout is hit. So if none of the actions I'm waiting for here happens, then the contract will continue with this. And here I can simply do close. So let's click on this and choose close. And let's put that in here. Okay, and now for this part. So I can again click on the when if I want, and then here on case, or I could immediately click on actions. So there are three. Notification is a special construct that's not used very often. So we'll mostly look at deposit and choice. Let's start with deposit. Slot that in here. Now we see we have lots of new holes. So we have to say who is to make the deposit, how much, in which currency, and into which internal account, and what should happen afterwards, after the deposit is made. Okay, let's click on this so we see the various holes here. So first, who is supposed to make the deposit? That's a so-called party. So it represents a participant to the contract. And there we have two choices. We can give a fixed party by specifying a public key or public key hash, or we can pick a role. So let's do this, and we can give it a name. So let's call it giver. So the giver has to make the deposit. Now how much? I think I said 100 ADA. So we need a value here. There are lots of options. So you can do arithmetic with values. So given two values, you can add them or multiply them and sorts of other things. But in particular, there's also this constant here. So I can use that and say 100 ADA, but actually this will be loveless. So I should say 100 million. 1, 2, 3, 1, 2, 3. Now the currency should be ADA. I click here on token. I could either specify a native token with policy and token name, or I can choose the special case ADA, slot that in here. Now into which internal account? So let's say into the giver's internal account. So again, a party and giver there. And finally, what should happen afterwards? So once the money actually is deposited, I can do a payment. So now I need another contract. So now this pay contract makes sense. So payee is who is getting paid. And there now I have two choices. Account off would be an internal account, or I can make a payment to an external wallet. So that's what I want in this case. So I use this. and I have another hole. I must now specify a party again, and this will now be a different party. That's the receiver. Now I must say how much, and again, token and from where it's supposed to come. So I can replicate what I did there. There are other options. For example, let's just for variety's sake, for value, let's not use constant 100 million this time, but use this value construct, available currency from account of. So I just say everything from the internal account of the giver. So available currency. So this is now token data from account of party giver. Oops. Of currency ADA from account of party giver. And finally, what should happen after the payment? Well, then we are done. So actually I can also copy paste. So Control C, Control V copies this, and I can put the close in there. So to recap, what does the contract do? It's a when. So if none of the actions specified here happens until the timeout specified here, we immediately close. So nothing happens. If one of the action happens, in this case, it's a deposit from the giver, constant value 100 million, ADA, to his own internal account. Then we'll make a payment to the external wallet of the receiver. Value will be the available ADA from the giver account, which in this case, at that point, after the deposit has happened, will be 100 million. ADA from the internal giver account, and then continue with closing. So let's try it out. Send to simulator. We can specify the initial time. So by default, that will be set to now. So this is when I'm recording this video, and I can start the simulation. So if I don't do anything and wait until it has expired, then nothing will happen. If, however, the giver makes the deposit, then we see giver deposited 100 ADA from his wallet into giver's internal account, and then the contract pays 100 ADA from the internal giver account to receiver wallet, which is what we wanted. Another way to write Marlowe contracts is not to use Blockly, but to use Marlowe directly. And this is actually not as complicated as it sounds, because there's a lot of support in the editor to help you get the syntax right. So for example, if I just type a W, I get when, and all the other constructs I can use at this point. So let's do when, and I get these two holds for the timeout and the contract that should happen if the timeout is hit. And I even get this quick fix button here. So when I click that, I get the two possibilities for the timeout, the absolute value or a parameterized value. I chose the absolute value before, but let's now do a parameterized value. So I can give it a name. Let's call it deadline. And now for the continuation contract. So if the deposit is not made, what should happen then? And let's again do this quick fix, and I can choose close. So now here I need my actions, and there it's a so-called case. So we only had one case. We were only waiting for a deposit, but there can be several actions we wait for. So then whichever of the two or more actions happens first is the one with which the contract continues. So we'll see examples of that later. So we need case, and now we can get two holds. So the action we are waiting for and what should happen if that action actually happens. So we're waiting for a deposit, and then earlier in Blockly. So we waited for a deposit of the giver to its own internal account and then made a payment from the internal giver account to the external receiver wallet. Actually, there's a simpler way to achieve the same effect because close is actually not as boring as I made it out to be until now. So one thing that close does is it pays all the internal accounts to their external wallets, which means that if instead of making the deposit to its own internal account, the giver makes the deposit to the receiver's internal account, then if afterwards a close happens, automatically the contract will send that internal value at the receiver internal account to the external receiver wallet. So here we can simply do a close. And now here we do a deposit from the giver to the internal receiver account. So and do deposit. I get a bunch of holes. So party from party. So I never know which is which. I mean, there are two parties. One is the receiving internal account. The other one is the originator of the payment. But in this case, luckily, it's easy because from party, the name makes clear that this is the person or the party that pays. So that should be our giver. So public key or role. So role giver. So then this is the receiver. Token. Here we only get one option. In Blockly, we also got ADA as an option. Here there's only this token option. But as it so happens, ADA is also a native token, a very special native token, where both policy and token name are the empty strings. So just like this is actually ADA and the value. And there we had constant 100 million because it's actually loveless. And that should be it. So we can switch back and forth between Blockly and Marlowe. So this would be the Blockly representation. Of course, it's somehow nicer and easier to use Blockly directly. But when you get more experienced, maybe it might be easier and quicker to actually directly use Marlowe, especially if you know what constructs are available. But with these autofill, autocomplete, and the quick fix and so on, it's actually relatively nice to do Marlowe directly. So let's see whether that indeed has the same effect. And now we have this new feature that instead of a constant deadline, we gave this parameter. So if we now send it to simulator, earlier we just had the initial time, but now we can also specify this parameter, the deadline. And automatically the simulator will set that to 5 minutes after the current time, which is actually quite nice. So we can just take it like this and start the simulation. And now if we do the deposit, then giver deposited 100 ADA from his wallet into receiver's internal account. And then we hit the close. And then because of this behavior of close to pay internal accounts to external wallets, the contract pays 100 ADA from the internal account of receiver to the receiver wallet. So we again get the effect that we got before, that giver deposits 100 ADA and then they immediately go to the receiver without having to use the pay construct. So this was a first simple example of how to write a Marlowe contract using Blockly or using Marlowe directly. And next we will look at some more of the available constructs.